All right, question number 11. This problem is similar to one in our text. It is quite lengthy, but we're going to try to find the shortest ladder that would fit up against the house. And so I'm going to draw a picture of this scenario, and then we'll work it out step by step. It is quite long, so do bear with me. All right, so number 11, we have a house. I'm just going to use that as the house. Ground is so long. And then we have a fence part way, not quite as tall as the house. Fence is 6 foot. The distance from the house to the fence is 5 foot. And then we're going to put a ladder up against the house so that it just clears that fence and hits the ground. I want to find the shortest length of this ladder. We can call the length L. What we have is a right triangle, so we're going to need to do Pythagorean theorem. We'll call this side, we don't know how high the ladder goes up to the side of the house. We'll call that A squared plus B squared. Now, the B squared at the bottom is broken into two pieces. The distance from the house to the wall, and then the distance from the house to the fence, and then from the fence to the ground where the ladder meets. We'll call that X. And so I'm going to set up Pythagorean theorem. A squared plus B squared, which is going to be X plus 5, A squared plus B squared equals C squared, which in this case will be L squared, the length of the ladder. We have one equation and two unknowns, so I want to try to solve for A, or find another equation that represents A. And what we have is similar triangles. So we have this big triangle, and then we have this little small triangle here. We'll set up a ratio. So this side to this side is this side to this side. So A to 5, or X plus 5, is equal to 6 over X. Okay. Solving for A, we can multiply by X plus 5, and that will give me A equals 6 times X plus 5 divided by X. All right, so now I have A in terms of X. So I have one equation, one unknown. I'm going to plug that in. A squared is now going to be 6 times X plus 5 divided by X, this whole thing squared, plus X plus 5 equals L squared. Now, normally we would take the square root of both sides. That's going to make it much more messy, but the purpose of this is we want to find the derivative so we can minimize the ladder's length. The critical value for L squared will be the same for L, so it'll be easier to take the derivative with L squared and then just go back and plug in. So we're going to leave it as L squared. We're not going to take the square root. We're going to solve this, and then when we go back and plug it in, we will do the square root to find the actual length of the ladder. All right, so we're going to simplify. I'm going to square this and this binomial. So 6 squared, 36, X plus 5 squared. So that's going to give me X squared, multiply double, plus 10X plus 25. So what I'm doing is some mental math with the binomial formula. You can do the FOIL, and you'll get this. There's a shortcut that says if you have A plus B and it's squared, or if it's A minus B, the formula is A squared plus 2A times B plus B squared. And so that's what I did. I squared the first term, multiplied these two together, and then times 2, and then squared it. So that's where I got that. And this is all over X squared plus x squared plus 10x plus 25 equals L. From here, I'm going to simplify this part a little bit more. So this is going to be 36x squared plus 360x plus 25 times 36. 4 is 9. It'll be 900. No. Trying to do some mental math. Let's check with the calculator. 36, 25. Yep, we get 900. Okay. I can do a little math. All right, I want to do the derivative. I don't want to do the the quotient rule. So I'm going to divide each term by x squared and write these as negative exponents. That way I can just do the power rule, and then we'll simplify from there. So I'm going to divide this divided by x squared. We'll get rid of x squared, leaving me with 36. This divided by x squared, one of the x's will cancel out, leaving me with 360x to the negative 1. And then this will be plus 900 x to the negative second power. And then each of these terms, x squared, 10x plus 25 equals L squared. All right, now we're going to do the derivative. Okay, so we're going to do d dx of this. We're calling this like, just think about this as like a f of x, some kind of function for right now, because we're not doing times 2 over here. We're just doing this side. Derivative of a constant is 0 times negative 1, negative 360, subtract 1. That will be x squared. So I'm going to put that on the bottom. Go ahead and write it like it should look. Times 2 minus 1800. And then minus 1 up here, so it'll be a negative 3. So this will be over at x cubed. This will be plus 2x plus 10, and derivative of a constant is 0. So now we're at our derivative. All right, we're going to clean this up a little bit. So since we have a fraction, we're going to put all of them over common denominator of x cubed. So I'm going to multiply top and bottom by x here. This one is fine. Top and bottom by x cubed, and top and bottom by x cubed. So I can get one fraction with x cubed. And I'm going to rearrange this, putting the positives up front. All right, so I'm going to have one fraction with x cubed. Everything is going to have a denominator of x cubed. Times x cubed will give me 2x to the 4th. Times x cubed will give me 10x to the 3rd. This one is already over x cubed. This one I need 1x. So that'll be minus 360x. And then minus 1800. All right, we're going to set this equal to 0. So once we find our derivative, we set it equal to 0. And then, we're going to solve. So I'm going to multiply by x cubed to get rid of the fraction. That's going to leave me with, kind of running out of room, it's going to leave me with 2x to the 4th plus 10x to the 3rd minus 360x minus 1800, all equals 0. We need to factor. We got 4 terms, so we do factor by grouping. I'm going to group these 2 together and these 2 together. Greatest common factor will be 2x cubed. 2x cubed That'll leave me with the x plus 5. When you take out 2x cubed, 10 divided by 2 is 5. When you do factor by grouping, whatever's left needs to be the same. So the only way that I can get this to be an x is to factor out negative 360. So we're going to say negative 360. And then check if 1800 should be divisible by 360. Hopefully give us a 5 is what we're looking for. 1800 divided by 360. And we get a 5. Okay. So factor by grouping works. Factor out that negative. Negative divided by negative is positive. And then you do one more factor. This and this, they both have x plus 5. So factor out the x plus 5. And then what we're left with is the 2x cubed minus 360. All right, so we'll set each of these factors to 0. Now, the x plus 5 cannot be equal to 0, but if you do it, we'll get a negative number, and x cannot be a negative length. And that's the same thing here. X plus 5, that cannot be equal to 0. But if you did it, it says x is negative 5, and that does not make sense. Can't be a negative length. And so we'll set 2x cubed minus 360 equals 0. Add 360, we get 2x cubed equals 360 positive. Divide by 2, we get x cubed equals 180. And then we take the cube root. All right, so the cube root of 180, I'm going to go math, 4 cube root of 180. And that gives us 5.646. I think I'm going to use 3 decimal places, 5.646. So x is approximately 5.646. All right, I'm going to take this x value, plug it into this formula, and we're going to do the square root. So to find the actual length of the ladder, we're going to do L equals the square root of this function. So it's going to be 6 and then x plus 5 over x whole thing squared plus x plus 5 squared. So this is what we're going to do. X is equal to 5.646. All right, so what I'm going to do, I can do the exact value. I'm going to have the calculator save this value. You can round, but I'm going to have it saved, so I don't have to keep typing that in. This STO button means store. So it's saying store this answer, and it's waiting for an input. I'm going to tell it to store it into X. That's going to be the variable. So I'm going to hit enter. And then what happens if I hit X and hit enter, it gives me that value. So that's what is the value of X. So now I can type in this expression. So I'm going to do second square root. I'm going to make a fraction bar. Well, let's do parentheses and then alpha y equal enter to make that fraction bar. All right. So far, so good. We're going to type that in. So 6 and then x plus 5. And x plus 5 is that value, 5.646. It did the whole thing. Go down to the bottom, put an x, close parentheses, and squared. So this is like my a squared plus b squared plus x plus 5. So this is a lot nicer, just being able to type in x instead of having to type 5.46 something every time I need to put that in. All right, so this is my function. I'm just double checking to make sure everything looks right. Data entry is the most common error. Everything looks good. I'm going to hit enter. And then the length of my ladder is 15.5. I think it says around the 1 decimal place. 15.5. Looks like it's within our limits. Our limits, the house is 20 feet high. And then the ground goes 25 feet. So our ladder is less than both of those. We got 15.5 to 1 decimal place. Okay. So the length of that ladder is 15.5.